This is the second in a series of lessons about programming with C# for beginners. In this lesson, I'll show you how to use a text box on a form to collect some input from the user of your application. I'll also show you how to declare and initialize variables to temporarily store different types of data while your program is running. You'll also see how to output the contents of variables. I'll begin by placing a text box on the form. There's the text box underneath Common Controls in my toolbox. It's good practice to name these controls as you place them onto the form. I can do this in the Properties window. TXT name, because I'm going to invite somebody to type in their name. I'm also going to put a label on the form so that they can see what the text box is for. LBL name, notice the convention I'm using, LBL for a label, TXT for a text box. You don't have to, but I think it's a good habit to get into. You'll see the benefits of it later. For a label, I also need to change the text property. If you wish, you can experiment with some of the other properties you can see here, like the background colour, the foreground colour. There's options here to change the font size and the font type. I'll leave that to you. I'm also going to need a button to launch my program. That's the text which will appear on the button, and that's the name I'm giving to it. Notice that a control name can't contain spaces, which is why I'm using so-called camel notation, a capital S and a capital H. I've also prefixed it with BTN because it's a button. Furthermore, every control that you place onto a form must have a unique name. You can't have two buttons called BTN Say Hello, for example. OK, to write the code, just as I showed you in the first lesson, I double-click the button. And my cursor is conveniently positioned for me to start writing my code. Get used to using the drop-down lists like I am, and that will help to ensure that you're using the correct case. Remember, we saw that these commands are case sensitive. For example, I have to type show with a capital S. Notice I'm using plus signs here and here. That is the text property of my text box, which I called TXT name. So the whole message reads as, "Hello, Kevin," for example. "I hope you are well." These are called concatenation operators. I'm using them to join together three separate strings. Hello, which is a literal string because it's in double quotes, txtname.text, which is the contents of the text box, and then another literal string, "I hope you are well." Let's put in another command. Notice how I've included a space before the double quote. I want this to be part of the message. Then the concatenation operator. And when I type TXT, you can see a drop-down list containing any controls on the form whose name begins with TXT. You can start to see the benefit of using this naming convention. If the names of all of the text boxes on my form start with TXT, I'll see them in this list. I can use my arrow keys to highlight the one I want, and then select it with the Tab key. Let's give it a try. Hello, Kevin. I hope you are well. Soon you will know all about C#. System.windows.forms.textbox. Text, Kevin. Something's not quite right here. Let's take a look. I've put the name of the text box here, but I haven't said which property of that text box I want to include in my message. It's the text property I want. That's better. And remember, we saw last time, C# is case sensitive. It doesn't matter what I type inside a literal string. But when it comes to commands or referring to controls on a form, I have to be careful. The text property has to be referred to with a capital T. Now, I want to declare some variables to store data. When you declare a variable, a certain amount of space will be reserved inside the computer's memory for your program to use. The amount of space depends on the variable data type. I'll say more about that in a moment. I'm going to write my declarations at the top of the procedure, so I'm giving myself a little extra room in between these two curly brackets. First of all, I want a variable that will store some string data. It's going to store my name, so I've called the variable name. I can see a green wavy line here. That's just a warning. The variable name is assigned, but it hasn't been used. So I've declared and I've assigned a value to this variable, but I haven't done anything with it yet. That's fine, I'll get round to it. I'm going to declare another variable now to store a single character, my initial, C for Christopher. For just one character, I'm using single quotes instead of double quotes. And then another one to store my shoe size. I want to store a whole number, so I've used a data type of int, which is short for integer. Notice as well, I haven't used any quotes, single or double. Quotes aren't necessary when it comes to numeric values. Now there are a few things I'd like to point out at this stage. When you declare a variable, you need to give it a meaningful name. So if you're going to store somebody's name, call it name. Or better still, first name, because I'm storing somebody's first name. We also have to declare the variable with a data type. So this first variable has a data type of string. I'm going to store a string of characters. The data type has a bearing on how much space will be used in my computer's memory to store this data. With a string variable, I'll need 2 bytes per character. So if I'm storing the word Kevin, then I'm going to need 10 bytes. If I only want to store a single character, I can declare a variable of type char. This will only need 1 byte of memory. And to store my shoe size, I've used a variable of type integer. An integer will take up 4 bytes of memory. Integers can be negative numbers as well, so the value can range from about -2 billion to +2 billion. Let's declare a few more. I'm using a data type of long this time. That means a long integer. So it's a whole number, just like int, but this will take up 8 bytes of memory. That means the number can range from about -9 quintillion to +9 quintillion. I read somewhere that this is the distance somebody will walk by the time they get to my age. Let's have another variable to store how tall I am. A data type of float will allow me to store real numbers, that is, numbers with decimal places. I can have up to 6 or 7 decimal places. This takes 4 bytes of memory. Notice the suffix capital F after that value to indicate that I want this to be stored as a float, that is, a floating point number. I can also use a double data type. A double data type requires 8 bytes of memory, and it will allow me to store up to 15 decimal places. The existence of the double data type is the reason I had to include a capital F with my height. Without this, my height would have been stored as a double, and it would have taken up more memory. You needn't worry too much about the details of floats and doubles. Suffice to say, use one or the other if you need to store a number which isn't an integer. There's one more data type I'd like to show you, and that's the Boolean. A Boolean variable requires 1 bit of memory. It can store a value of true or false. The Boolean data type was named after George Boole. Now let's try to output the contents of some of these variables. There's a few things you need to be aware of. I'll start by outputting first name. No problem there, nothing new. Let's try outputting my height. I can see a red wavy line. Cannot convert from float to string. MessageBox.show expects to be supplied with a string. My height is not a string. To output this using MessageBox.show, I need to convert it to a string first. And I can do it like this. Height.toString. That's better. There's another way I can do this. Convert.toString. This particular way of doing it is more flexible. You'll see later that I can use it to convert from one data type to another, which isn't necessarily a string. Now I'm going to show you something that might strike you as a little bit strange. No error message, no red wavy line. If I start with a string and then I concatenate a numeric value onto it, then I'm implying that I want to convert the height to a string so I can join the two together. This is called implicit type conversion or implicit casting. When I used convert.toString, I was using explicit type conversion. I was explicitly casting from one data type to another. Let's try this. That's fine as well. The fact that I'm concatenating a numeric value to a string is all I need to do to let C# know that I want to implicitly convert from one data type to another. Now let's try to build some user-friendly messages using the contents of these variables. Strictly speaking, there's no need for me to use .toString for the shoe size and vegetarian variables. The fact that first name is already a string and I'm attempting to concatenate them all together implies that I want them all to be strings. However, explicit casting will make your code a little more efficient because the compiler doesn't have to decide whether or not something needs converting. You've already told it. I've concatenated \n into my output string a couple of times. Watch the effect of this. It's putting a line break into the message box. Notice also I concatenated a space here, so I could have a space between Kevin and the initial. You might remember from the first video, it doesn't really matter if I press the Enter key, here for example. It's all the same line of code. A semicolon defines the end of a line. So if this instruction gets too long, that's fine. I can wrap it around if I need to. Now the whole point of a variable is that its contents can change while the program is running. So I'm going to assign some new values to the first name, the initial, and the shoe size. Notice I'm not specifying the data types again. I don't want to declare these variables again. I'm simply giving them new values. And we'll do the output again. I'm making good use of copy and paste. Control-C to copy, Control-V to paste. So there's my first message. And there's the same message after I've assigned different values to those variables. Now, of course, I can collect data from the form. Let's put some more text boxes on the form. And some labels. Now I've ran into a little problem here because the variable called initial has been declared as type char. But what I collect from the form in a text box is a string. So in order to populate this variable with the contents of this text box, I'm going to need to convert this into a char. And I'm going to have to do something similar with the shoe size. I have a number of options here: 2int16, 2int32, 2int64. I'm going to use a 32-bit, a 4-byte integer, although that is quite excessive for a shoe size. And let's get the vegetarian status as well. I'll need another text box. Property value is not valid. I'm only allowed to use letters and digits for a control name. Special characters such as question marks, exclamation marks and the like are not allowed. As it happens, the same rules for control names on a form apply to variable names. The text property can be anything I like. By the way, when you're testing your application, if you don't input the correct type of data for each text box, for example an integer for the shoe size or a single character for the initial, or if you leave any text box other than the name empty, your program will crash. I'll show you how to prevent this in another lesson. For now, I suggest you just input all of the data that the program is expecting. Now you might be wondering, why did I bother to convert the shoe size into an integer only to have to convert it back to a string again when it comes to displaying it? Well, I might want the shoe size to be stored as an integer so I can do some calculations with it later on. Here's an exercise that you might like to try for yourself. See if you can build this application. When the user inputs their personal data and presses the button, a single message box displays everything they entered. The message is a mixture of literal strings and the data that were input. There are line breaks in there as well to make it more readable. Each data item is stored in a separate variable with an appropriate data type. Needless to say then, there is some data type conversion going on in the program. If a different set of data are input, the message is different. By the way, I've used a variable data type that I haven't shown you yet, the date time. Pause or stop the video to give it a try, and I'll show you one possible solution in a moment. And here's my solution. The procedure that runs when I click on the button begins by declaring all of the variables that I'm going to need. Notice I haven't assigned any values in the code. There's no need because all the data are coming from the form. These are just declarations. I've used the data type double for all of my real numbers, and I've used date time for the date of birth. When the data are collected from the text boxes into the variables, I've had to explicitly convert some of these data items from one type to another, because a text box will always capture a string. In other lessons, you'll see some of the other types of form control available for capturing input, and you'll see how to handle them in your code. Controls such as list boxes and radio buttons, which I could have made good use of here. And here's the message box. This is a single line of code. There's only one semicolon at the end, but I've wrapped it several times to make it more readable. And I've used \n whenever I wanted to throw a line break inside the message box. Finally, here's a problem that you might well have come across by now. And if not, you no doubt will one day. I'm going to attempt to display a message with a non-numeric value for the shoe size. My program has crashed at runtime. The reason is, it's impossible to convert the word 10 into an integer. I would see a similar message if I was to simply leave this text box empty, because by doing so I would still be attempting to input a string, albeit a string with no length. Visual Studio is now in break mode or debugging mode, and there are various tools available to help me track down any errors. I'll say a lot more about debugging in another lesson, and I'll talk about defensive programming techniques, so you can prevent your program from crashing in the first place. For now, if your program does crash, just reset Visual Studio by clicking here.